We are going to continue with 2.4, which is the values of 6 basic trigonometric functions. But before that, let's review a bit about sine and cosine functions, because if you understand about sine and cosine functions, 2.4 will be so brief, okay? Trust me for that one. So let's say if you are asked what is sine A, so you have a right triangle over here, ABC. So if that is sine the angle A, what is sine A? Sine A will be equal with A over C. What is cos A? Cos A will be the adjacent sides over the hypotenuse, B over C. So if I change the questions, what is sine B? Sine B will be the opposite sides of angle B, which is B over the hypotenuse, C. And then cos B will be equal with A over C. So you notice something over here. C is never changed whether you have angle A or angle B. But the opposite and adjacent sides is changed depend on the angle. For angle A, you have the opposite sides is A and the adjacent sides is B. For angle B, you have the opposite side is B and then the adjacent side is A. So basically, sine and cosine is just the ratio of the length of the sides. Yeah, that's something for you to know. Okay, so then we have from 0 to 90 degree by the definitions. We have learned yesterday how we get the sine and cosine for 45 degree. We have derived that, so I will not do that again today. And I need to change this to half square root of 2. And we have learned also how we can get 30 and 60 degree from the equilateral triangles, and how we can derive to this value. Okay, so I will not get too long for this one. Let's have it from 0 to 360 degrees. So before we have 0 to 90 degree, and this is basic foundations that we can have from 0 to 360 degree, because like 90 to 180 degree, that's also using the reference angle. Yeah, so let's see. This is cosine alpha and how it varied from 0 to 360 degrees. So you notice that on the third quadrant here, 233 degree, it becomes negative, and then at second quadrant it's also become negative. Other than that, it's always positive. Yeah, so if we have that, then we can plot the y equal with cos theta and y equal with sin theta. Yeah, so this is the graph look like. If you are told to graph it, then this is how you are going to do it. Make two axes. Don't forget to label the axis. 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 Okay, and then you'll have let's say y equal with sin theta. Put the maximum and minimum point 1 and then negative 1. Put the maximum point. Okay, put the maximum point, and then you'll have this, and then put the degree 0 up until 360 degree. In the middle you have 180, you get 90 in the maximum point, and then 270 at the minimum point. That's how you graph it. Okay, don't put it this way. Yeah, and then I have no clue what are you drawing. Okay, let's move to next one. So some students ask me about the questions on 2.3. I have taken this from your textbook on the even numbers. So let's say if you are told to sketch for y equals 4 cos theta plus 60 degree, we know that the parental function is y equal with cos theta, right? So this is y equal with cos theta. Y equal with cos theta. How to draw y equal with 4 cos theta plus 60 degree? So we know there are some transformation happen from y equal with cos theta to these new functions. So it must be 4 is the vertical dilations by a scale factor of 4, and then we also have, this is 60 degree is a horizontal dilation by negative 60 degree. It means that it's shift to the left by 60 degree. So let's put some points over here in order to help us to get the image. Okay, so I put some points. Okay, this is the critical point. I have the maximum point, the inflection point, the minimum point, inflection point, and then the maximum point again. This inflection. Okay, this is the minimum, and then this is the maximum. Okay, and if we have like this one 0,1, okay, 0,1, and then it transformed by vertical dilations scale factor of 4, put 4 over here, and horizontal dilations by negative 60 degree, then it will be, yeah, vertical dilation first. So I have 0,4, and then I have shift to the left by 60 degrees. So I have the point over here. Okay. For the second, I have 90,0. So 90 times with, sorry, vertical dilations by scale factor of 4, still same because 90,0, right? And horizontal dilations by negative 60 degree, it means that it moves to the left side by 30 degrees. So this is what I'm going to have. And then if I have the minimum point, then it will be negative 4, and then switch to this point. Okay, so I'll have it over here, and then 270 will be over here, and then last one, the 360 degree, it dilated by 4 units, moving here and shift to the left, so it will be over here. Let me erase, or no erase lah, yeah, over here. Yeah, I think I need to erase, so you can find it as f of 4, and then we have it over here. Yeah, so the graphic will look like this. Okay, make a smooth curve, yeah, not a line. Okay, so it will be something like this. I'll show you a better shape. Okay, so this is what we have. Yeah, a better smooth curve. Okay, then we are ready for 2.4, which is the values of 6 trigonometric functions. We have learned sine, cosine, and tangent on 9th grade. Okay, so let me repeat it again. Sine is opposite over the hypotenuse, cosine is adjacent over the hypotenuse, and tangent is the opposite over adjacent. Sometimes tangent can also be written as sine A over cos A. So if we taken this value, sine A is A over C, and then cos A is B over C, and I put it over here, I'll have A over C over B over C, which is equal to A over C times with C over B, which end up as A over B. Yeah, so this is correct. Yeah, sine A over cos A. So since these 3 we have learned, okay, the other 3, which is cosecant A, secant A, and cotangent A, is new for us. Cosecant, this is how you spell it, cosecant, and then this is secant, and then cotangent is this is how to put it, cotangent, sorry. Okay, so cosecant is defined as hypotenuse over the opposite, which is the reciprocal of sine A, and then secant A is defined as hypotenuse sides over the adjacent side, which is the reciprocal of cosine, and then cotangent, yeah, you can guess, it's also the reciprocal of tangent. Yeah, so if you have A over C for sine A, you'll get for cosecant is C over A. If you have cos A is B over C, then secant A will be C over B. and if you have tangent A equal with A over B, then you'll get cotangent A is B over A. So if you can find this value correct, then you'll get correct also for this letter 3 definitions. If one of these wrong, then you get two or three will be wrong also. Okay, so make sure that you know about this. If we can define from sine to cosecant, then we will be able to define the value, from 0 to 90 degree. So this is what it looks like. If sine and cosine, I already give it. Tangent, same like before, tangent is like what I say, is equal to sine theta over cos theta. Okay, get used with put it sine theta and cos theta. Don't just write sine over cosine. You'll get wrong. Okay. What is tangent of 0 degree? So it means that you divide sine with cosine. 0 divided by 1, you get 0. How to get 30 degree? Then it will be half divided by square root of 3 over 2. Then you'll get 1 over square root of 3. And that's supposed to be 1 over 3 square root of 3. And for 45 degree, same. You get 1 over square root of 2 divided by 1 over square root of 2, which is equal to 1. I need to change this into half square root of 2, half square root of 2. Okay, so the other square root of 3 and not defined, like 1 divided by 0, that will be undefined. Okay, and the other 3 over here is just the reciprocal of it. Cotangent is the reciprocal of tangent, tangent theta, and then second is the reciprocal of cosine theta, and cosecant will be the reciprocal of sine theta. So you look on, like for tangent, for tangent you will look at tangent theta. To get the value, that will be 1 divided by 0, which is not defined. To get square root of 3, that will be 1 over square root of 3, which is square root of 3. And then 1 divided by 1, that will be 1. To get secant theta, you'll need to understand cosine theta. So that will be 1 divided by 1, you get 1. 1 divided square root of 3 over 2, you get 2 over square root of 3, which is equal to 2 square root of 3 over 3. Kebiasaan ini, radikalnya. Okay, and the same thing with cosecant, you look on the sine theta. That's how you get it. Okay, and then this is 2 over 3 square root of 3. Ini juga nih, Mr. Martin bakal marah nih. Okay, let's move to the next one. Let's say so that's quite brief, right? I mean 2.4 is just that to learn about the values of 6 trigonometric functions. So if you are told to find the value, there are two kinds of value. One is the approximate value, and the other is exact value. The approximate value you can use calculator, and on your calculator you only have sine, cosine, and tangent. So if you have these three questions like cotangent of 140 degree, you try to look at your calculator, you'll never find it, okay, unless you have a different calculator. So most of the calculator will be just like that, and you'll not have cotangent. So you need to define again cotangent of 140 degree. That will be 1 over tangent of 140 degree. So that will be equal to 1 over negative 0.839, which is around negative 1.192. I will require you to put it to 3 decimal points. Second of negative 53 will be 1 over cosine of negative 53, and that will be equal with 1 over 0.601. Okay, so it's not negative, so you'll get 1.662, and then cosecant 238 degree, that will be 1 over negative sorry, not negative, 1 over sine of 238, and you'll get 1 over negative 0.848, which is around negative 1.179. Misconceptions. Okay, so there are many misconceptions happen when you try to find cotangent of 140 degrees. Some students will put it as a tangent 1 over 140 degree. This is wrong. Yeah, it's supposed to be this one. Or when you have secant of negative 53 degree, some students also put it as a negative 1 over cosine 53 degree. Yeah, this is also wrong. Yeah, so fix that conceptions. Okay, it's supposed to be like that. The exact value. So we come to the exact value. I give like 3 examples of exact value. I hope that we can finish it faster. Find the exact value of the 6 trigonometric functions of the angle in standard position whose terminal side contains the given point negative 12,5. So it's better to redraw it again, right? Negative 12,5. Then it will happen on the second quadrant. Yeah. Okay, negative 12, and then I have 5 as the vertical axis. This is U and V. And we are told to find the 6 trigonometric functions, which is, let's say, sine theta, cos theta, tangent theta, and then cosecant theta, secant theta, and cotangent theta. Okay, how to find it? Since we have drawn this, okay, let's put the reference triangle outside. So I'll put it here so we can see it clearly. We have that this is negative 12, we have this is 5, but we don't know what is the hypotenuse. Can we find the hypotenuse? Yes, by having h square equal with negative 12 square plus with 5 square. So you'll get square root of 12 square plus 5 square. That will be equal with 13 briefly. Okay, and then from there, oh yeah, since we know all of this, we can just change h, okay, as 13. Then we are ready to get sine theta. Sine theta, again, theta is over here. That's the reference angle that we are using. Sine theta will be 5 over 13. Okay, cos theta will be negative 12 over 13, the adjacent side. Tangent theta will be negative 5 over 12, or 5 over negative 12, which is same. Yeah, okay. And then cosecant theta, secant theta, and cotangent theta. Notice, if you do this correctly, you can be assured that you are halfway to answer this. But if you do this wrong, then big chance that you'll get these 3 wrong. Okay, so cosecant theta is just the reciprocal, so that will be 13 over 5. Secant theta is the reciprocal of cosine, then you'll have negative 13 over 12. And then tangent theta will be negative 12 over 5. Quite easy, yeah? Okay, let's move to the next one. If angle A terminates in quadrant 3 and has cos A negative 1 over 3. So put it like this, U and V, and then we have cosine A. Yeah, cosine A in quadrant 3. So this quadrant 3 has cos A of negative 1 over 3. Negative 1 over 3. So I'll begin with the definitions of cosine. Cosine A is equal with the adjacent over the hypotenuse. Now it says that cosine A is equal with negative 1 over 3. It means that we have the adjacent side is negative 1 and the hypotenuse is 3. Yeah, because that's the proportions of it. Yeah, even though that's not always true. You can have negative 2 and 6, negative 3 and 9, of course. But let's put it this way because that's just the ratio. And I will take out the reference triangle, put it over here, put this as the reference angle. I gave that this is -1, this is 3. I don't know what is t, and t is what I'm looking for. How to get t? T square t square plus with 1 square by the Pythagorean theorem, or using -1 square equal with 3 square. So you'll have t square equal with 9 minus 1. So t equal with square root of 8, yeah, or 2 square root of 2. Now I can change this into 2 square root of 2, but I must be careful since this is on third quadrant, so it will be -2 square root of 2 or negative square root of 8. If I know that, then I can answer what is sine theta, sorry, not sine theta, sine A, cos A, and tangent A. Let's fix this first and then we'll go to the other three. Sine A will be -2 square root of 2 over 3. Cos A will be -1 over 3. Tangent A will be -2 square root of 2 over -1. So that's also equal to 2 square root of 2. Yeah, and the other three is quite easy. For reciprocal of sine, you'll get cosecant A. It means that you have 3 over square root of 8. I'm sorry, I forget to put the negative. So we'll have -3 square root of 8. I'll just put everything over here. So you'll get -3 square root of 8 equal with -3 square root of 8 over 8, because we cannot have the radical under the denominator. And then secant A will be the reciprocal of it, which is -3, and then cotangent A will be 1 over square root of 8, because 2 square root of 2 is square root of 8. So I can write it as square root of 8 over 8. Let's get to the last, okay, which is this one. Find the exact value of 6 trigonometric functions of -240 degrees. So I think this is quite easy. Sine of -240, cos of -240. Wait, so to save our time, okay, I write it, and then -240 degree, we'll have it over here on the second quadrant. Yeah, because you will have it from here clockwise, and you'll get that the reference angle is 60 degree. So this is same by saying what is sine of 60 degree, cos of 60 degree, tangent of 60 degree, and so on. It's 60 degree. Yeah. Okay. Of course, we already know that sine of 60 degree will be equal to half square root of 3. And cosine of 60 degree will be equal to cosine 60 degree is equal to half. Yeah, but okay, let's try to answer sine and cosine first. Yeah, is this true? Because we have for cosine and sine, it looks like this. For sine, we have on the second quadrant, it will be positive, so this is true. But for the cosine, we have this kind of graph, right? On the second quadrant, it will be negative, so this one is supposed to be negative half. Yeah, and then tangent of -240 degree, that is just the division of half square root of 3 divided by -half, so you'll get negative square root of 3. And then cosecant, secant, and cotangent is just reciprocal of it. Then you have 2 over square root of 3, or equal to 2 square root of 3 over 3. And then secant of -240 degree will be -2. And then cotangent of -240 degree will be 1 over 3 square root of 3. So that's it for today. Thank you.